Understand what photoelectron spectroscopy, PES, represents. PES measures the binding energy, or ionization energy, of electrons in various subshells of an atom. The position of a peak along the horizontal, X, axis represents the binding energy of the electrons in a particular shell or subshell. Standard PES scales increase from right to left, meaning peaks located further to the left represent electrons that are more tightly attracted to the nucleus and have higher binding energies. The height of a peak along the vertical, Y, axis is directly proportional to the relative number of electrons residing in that specific subshell. Analyze the electron configurations of hydrogen, H, and helium, He. Hydrogen, atomic number 1, has the electron configuration 1 to the power 1, containing exactly 1 electron in its outer shell. Helium, atomic number 2, has the electron configuration 1 to the power 2, containing exactly 2 electrons in its outermost, valence, shell. Account for the peak height difference. Because helium possesses 2 valence electrons in its 1 subshell and hydrogen possesses only 1, helium has twice as many electrons in this orbital. This stoichiometric difference dictates that the peak representing helium's 1 subshell must be twice as high as the peak representing hydrogen's 1 subshell. Account for the peak position difference. Shift to the left. Hydrogen has a nucleus containing 1 proton, nuclear charge of +1, while helium has a nucleus containing 2 protons, nuclear charge of +2. The valence electrons for both elements reside in the same 1's energy level. Because helium has a greater nuclear charge, more protons, it exerts a significantly stronger Coulombic attraction on its electrons than hydrogen does. This stronger electrostatic attraction increases the binding energy of the electrons in helium, making them more difficult to remove. Consequently, the peak for helium is shifted further to the left on the PES energy scale. Select the correct option. Option B correctly identifies both factors. Helium has a greater nuclear charge, which increases the attraction of its electrons to the nucleus, and has twice as many electrons in its 1's orbital. The correct answer is option B. He has a greater nuclear charge than H, which increases the attraction of its electrons to the nucleus, and he has twice as many electrons in its 1's orbital.